All right, folks, can we all settle down for the next talk, please? So our next talk is Goodbye GIL, Exploring the Free Thread Mode in Python 3.13 and beyond by Adarsh Divakaran. Can we all give a big welcome to Adarsh Divakaran, please?
Hi everyone, good morning. Today we will be exploring the free threaded mode in Python. I'm Adarsh Divakaran. I'm currently working as a software engineering specialist in the human data team at XAI. Today we will be going over these things. So we will start with the global interpreter lock in Python. Then we will talk about the free threaded support. And we will do some performance comparisons between CPU and IO bound programs in free threaded versus the default interpreter. So let's start with the global interpreter lock. So it's a mutex in CPython, or it's a lock that prevents multiple native threads from executing Python code at the same time. So we can simplify that and tell that it's like a lock present in CPython, so that if you're considering simple programs, only a single thread will be executing code at any point in time. So this is like, we can think of like, we can just go into a single point. We can just zoom in at any single point in time, and we can see that there will be only a single thread is being executed at the interpreter level. So this means it can simplify many things. It can simplify CPython's memory management. It can simplify things for like extension developers. So they can make assumptions that only a single thread will be executing at any given point in time. But there are a few problems related to the presence of this global interpreter lock. So it limits true parallelism for CPU-bound tasks. So there is like no true parallelism. When we are considering a single point in time, there are only a single thread. There are no multiple threads executing at the same time. But in case of IO-bound tasks, this was not much of an issue. So let's zoom out and look into CPU-bound tasks versus IO-bound tasks. CPU-bound tasks means when we are running a script, if the burden is on the CPU, that's called a CPU-heavy or CPU-bound task. For example, if you are doing some calculations, computations, some data processing or data analysis like NumPy or something, so that will be a CPU-bound task. The heavy burden is on part of the CPU. And we have the IO-bound tasks, where the burden is on like IO operations. For example, we are reading from file, writing to a file, or we are doing some network operations like API calls or network requests. So these are called IO-bound tasks. So by default, the global interpreter lock was released. It will be released in IO-bound tasks. So the problem is with mainly the CPU-bound tasks. So this global interpreter lock limits parallelism in case of the CPU-bound tasks. So historically, we had to use multiprocessing as our concurrency primitive. So with multiprocessing, we have to spin up multiple processes. But with Python's multiprocessing, each process has like independent memory locations. So we have to do some inter-process communication if we need to share some data between these processes. So for these, the Python enhancement proposal 703, PEP 703 was introduced. So it proposed making the global interpreter lock optional in Python. So it proposed introducing a free threaded build where the global interpreter lock is disabled. So this will allow for true parallel execution of Python threads, and it will be really helpful in CPU-bound workloads. Now, this was introduced in Python 3.13 as an experimental feature. But there were like a few issues or challenges. So one was backward compatibility. So previously, everything was written in the expectation that there was this global interpreter lock, and there will be only one single thread executing at a single point in time. So there were many C extensions which were expecting the same. And for free threaded builds, it will have like a performance overhead when running single threaded code. For example, when we are like doing single-threaded operations. Previously, we had GIL, but right now we have to introduce some additional code for like preventing race conditions, memory management, etc. Previously, we had this lock. Now, because this lock is not present, we have to do some memory management, race condition prevention from our own side, from the interpreter developer side. So that will introduce some performance overheads in case of single-threaded code. And coming to Python 3.14, so we'll be doing some demos after this, and we'll be using the 3.14 version of Python, and we had something called PEP 779. It was an acceptance criteria for free-threaded Python. So it proposed some set of criteria which must be satisfied so that the free-threaded build will be accepted. So this was accepted in Python 3.14. So right now, the free-threaded build is supported starting with Python 3.14, and it will be evolved in coming Python versions. So this was the release schedule of Python 3.14. The first beta was released in October 2024, and the stable version is scheduled to be released in 2 weeks on 7th October. And in this version, we can see that the performance penalty is on an average 5 to 10% when running single-threaded code. The free-threaded interpreter will be 5 to 10% slower on an average when compared to our default interpreter. Now, let's see how we can set up the free-threaded mode. So an official installation guide is available at this link. And if you are building CPython from the source code, we can use the disable GIL flag. For Windows or macOS users, it's very easy. We can use the official installers from python.org, and we can install the free-threaded builds alongside our default interpreter. For Ubuntu or Debian-based systems, we can add the Dead Snakes repository, and we will be able to install the Python 3.14 no-GIL version. Now, after installing, we can create a virtual environment using the free-threaded executable. So this will have like a T appended to its name, the interpreter name. So this means the free-threaded version of Python 3.14. So we can use it to create our virtual environments. And once we have set up the virtual environment and is running our code, we can verify these using these two flags. We can use a sys.isGIL enabled function, or we can get this config variable pygil disabled to check if the global interpreter lock is disabled or enabled. So now we are moving to the interesting parts, the benchmark. So we'll be comparing the execution time of free-threaded interpreter versus the global interpreter enabled default one with our latest Python 3.14 release candidate 2. And to get the context of this change, it was like it was a huge change in Python source code. So there were like 15,000 lines of code that were changed as a part of this change in Python 3.13. So let's move on to the benchmarks. So I have like two Python projects here. I have one with the default GIL-enabled Python 3.14, and I have another one with the free-threaded one. So let's start by checking the presence of the global interpreter lock. So I am using the various flags I have discussed previously. So let's run this with our default interpreter. So here we have the global interpreter lock is enabled in this case. Now going to the free-threaded project. The global interpreter lock is disabled in this case. So let's start working on the benchmarks. First, we will be executing a single-threaded program. We will time the execution of a simple math operation, and we will compare the results. So this is our first benchmark. We are finding the sum of numbers from 1 to 1 million. We are using Python's timeit to execute this code 100 times, and we are printing the execution time here. So let's try this. So it took 2.87 seconds here. Now let's go to the free threaded version. So it took 3.2. I have this results file, and we will be storing the results here. So the default version took 2.8, and the free threaded took 3.2. It's the same. So we can see that for single threaded code, the default Python interpreter is performing better compared to the free threaded one. So for single threaded programs, free threaded mode has a negative impact on the performance. Now let's look into an IO bound operation, IO bound program. Starting with our default interpreter. So for the IO bound program, we are doing this. We are creating a temporary file which is 24 MB in size, and we are creating 64 KB chunks, and we are writing each chunk one by one into the disk. So this will be the IO operation we are benchmarking. And for single threaded execution, we are doing this in two modes. We are doing it using a single thread, and we are doing it using multiple threads. For single threaded mode, we are running it 8 times, and for multi-threaded mode, we are running it 12 times using 6 threads. So what it does is that it writes to a file, it generates some random bytes, and it writes to a file by chunk, and after writing each chunk, we are ensuring that the change is persisted on the disk. So we need to make this some IO heavy work. So we are persisting that in the disk, and after writing, we are just reading that back to increase more IO work. So yeah, so that's what we are doing. We are opening the file, then we are doing a write pass, we are doing a read pass, and finally we will close and remove the file. In case of a single thread, we are doing it 8 times, and for multi-thread, we are using a worker of maximum 6 threads, and we are doing it 12 times. So we got this single threaded code is run in 2.9 seconds, and multi-threaded, it's completed in 2.4 seconds. Now let's do the same for the free threaded version. We have 3 and 2.4 here. Yeah, for the free threaded version, the single thread was completed in 3 seconds, and multi-threaded was completed in 2.2 seconds. And for the default interpreter, the single threaded execution was 2.9 seconds, and the multi-threaded execution took 2.4 seconds. So we can see that these are somewhat comparable. We get almost similar results. There is a slight penalty here, and for the IO bound multi-threaded, we are getting the same performance. Next, let's move to the interesting part. We are now testing a CPU bound program. So this is a program that will count prime numbers up to an upper limit. So this is our upper limit. We are choosing 2 million as our upper limit, and in case of multi-thread, we will split it into different chunks. Each chunk will process 50,000 numbers, and for single thread, we are doing it in a single pass. So this is like a simple prime checking code. We will check if the number is divisible by odd number up to the square root of the number. And we are using this count primes range function. It will take lower bound, upper bound, and it will call the is prime function to check the number of prime numbers. So in the single threaded case, we are like going from 2 to the upper bound, that is 2 million. And for multi-threaded, we are using different workers. We are splitting the task into different chunks, and we are processing them in a batch of 50,000. So let's run this with our default interpreter. So these are like taking around 2.7 seconds each. And we can see that in case of our free-threaded build, the multi-threaded performance is much better. It's 3.1 and around 0.9 here. So it's like 3.1 seconds for single-threaded and 0.9 for multi-threaded in the free-threaded build. And yeah, here we have 2.7 seconds for both of these operations. So we can see that the performance is greatly benefited here for a CPU-bound multi-threaded program. And now finally we can go to a web application. We are using a Flask application here. So for benchmarking our web application, I'm using a load testing tool called K6. Let's look that in more detail. So I have ran a Flask application using our default interpreter, and I am running a script using K6 run, K6 benchmark CPU.js. So this is our app.py file. This is our Flask application. So here we have a CPU bound task. It gets a sum of squares from 0 to 10 million. This is a heavy computation task. We have two roots. We have /CPU. So this performs the heavy computation. This is a CPU bound task. And we have another /IO. This root is just doing some file operations. We are creating some temporary files, writing to that, reading from that, and then removing that. So we have like a CPU bound endpoint and an IO bound endpoint. So we have run this CPU bound endpoint here, and now we are running the IO bound endpoint. So we can see that for the earlier run, we got 36 complete. This means that K6 is a load testing tool, so we can set the number of users. So here we are emulating 15 views. That means 15 virtual users will be sending requests to our CPU bound endpoint, and we got like 36 completed requests in that case. And right now we are benchmarking our IO bound endpoint, and we got 30 completed requests. So for the CPU bound, we got 36 completed requests, and for the IO bound, we got 30. Now let's move on to the free threaded. So I am running our Flask app here. This is our benchmark file. This is the benchmark CPU file. So it hits our CPU bound endpoint. So the virtual users are 15. That means it's emulating 15 real users sending network requests, and we will do this for 20 seconds. So this is what K6 does. it sends this request. So we can see that for the CPU we got 93 completed requests in this case. Now let's do the IO benchmark also. So this is running for like 20 seconds. So these 15 users will be sending network requests to our Flask server, and it will be calculating the total number of succeeded requests to that endpoint. So we got 30 completed requests in this benchmark. Yeah. Here also we can, we got 30 here. So here also we can observe the same thing. For CPU bound tasks, there is a great performance benefit. This is because when we are running a web application using Flask, so Flask is creating multiple threads under the hood. So it will create different threads to handle the user request. So this is actually a multi-threaded application, and we have like a benefit in the CPU bound use case. So these are the summary of our benchmark results. From this we can observe some patterns. Consider the single threaded programs. We have a single threaded program here, another one here, another one here. So either the default interpreter is either faster, it's faster in these two cases, and it's almost similar in this case. So if you are running a single threaded program, it's best to go with our default global interpreter lock enabled version of Python interpreter. And now let's look into the IO bound programs. Here we have one IO bound, another one here, and another one here. So for the IO bound use cases, there's like the performance is very similar. So we need not go with the free threaded execution here also. And now let's go to our special case. We can look into the CPU bound multi-threaded cases. So Flask has multiple threads. For the CPU bound workload, we get like a great performance benefit here. And also for the prime example, where we used a CPU bound program in multiple threads, we get a good performance benefit when we are using the free threaded build. So that's our summary. Free threaded Python greatly improves performance of CPU bound multi-threaded programs. Now, if you are looking to move to a free threaded build, so this is good for CPU bound tasks. And if you are using multi-threading already, it will be better to go with our new free threaded interpreter. So this is great for scenarios where parallelization is needed, but we cannot use multi-processing module. For example, in the Flask app, it's already using multi-threading by default. So if we have some Flask app in production, we can try to experiment with the free threaded build. So for this, I'm using a free threaded build of Python 3.14 RC2, but Python 3.13 was also showing similar benchmark results. So, but before making the move, we should always benchmark our code, our own code with both these interpreter versions. And also there is an issue we have to look out for. There can be library compatibility issues, as we have said. So the libraries we will be using should be like compatible with a free threaded build, or there may be some bugs. So we have to watch out for that. And the future is that in the coming versions, like after 2 to 3 releases, the CPython is planning to switch to the global interpreter lock disabled version by default. And right now, it's like in 3.13 it was experimental, 3.14 it was accepted, and in the future, the global interpreter lock might become disabled by default based on the evaluations by the core development team. And in summarizing, we can see that currently we have performance penalties for running single-threaded code in our free-threaded interpreter, but the core development team is working on optimizations, and in future the performance penalties will be reduced for the single-threaded code also. So yeah, concluding our observations, using the free-threaded build, great improvement can be seen in multi-threaded CPU-bound programs. So for single-threaded programs, we can go with default interpreter for now. And for programs using multiprocessing, we can go with the global interpreter lock disabled default interpreter. So that's it. Thanks, everyone. You can access the slides and code using our PyCon JP talk link, or you can visit this link to connect with me and get the slides also. Thanks, everyone.
Thanks for the wonderful talk. Any questions? Okay.
I mean, thanks for the talk. I wonder if you found any drawback of the free-thread Python version, like because all your data shows like it's just nice. So I wonder if you observe anything like under it.
Yeah. It's nice for actually CPU-bound multi-threaded programs, but for some single-threaded applications, it's not providing any benefits. The default interpreter is good for like this one. Single-threaded programs, we should go with default Python, and for like CPU-bound multi-threaded programs, we can use the free-threaded build. So another thing is that it affects the C extension APIs. So developers could write like extension APIs to Python using C. So there were like some previous extensions which were written with the which kept the guarantee that there is the global interpreter lock is present. So there might be some bugs here and there. So there is a have shared this link, like you can go to this Py free threading guide. So here you can see which all libraries. For example, you can see NumPy, Pandas. So there are like popular libraries here. So they are using C extensions to improve Python code. So some of these might be not compatible with the free threaded build. So there can be some bugs in our code. So it will be always better to benchmark our own code and run our test cases with the free threaded build so that we can ensure that it runs well.
Hi, I can see the single thread are not help too much with the free threaded mode. Do you think in the future, like say Python 4.0 or something, will it also help speed up the single threaded too, or do you think it's just going to be the future if they ever make the disabled GIL the standard from now on?
I think no. Right now, the goal is that they have to reach the current performance of the default interpreter build. So the problem is that the default interpreter single-threaded mode, we have everything like we have this guarantee that let's think of something like an ATM machine. So only one user is using that at a time. So we go, one user perform the transaction and they will return. But suppose we have to do something, we have to introduce like multiple users. So ATM can be used by 2 persons at a time. So we have to do some code, right? We had to ensure separation, like one user cannot access other users' data. We have to support 2 displays. So that's the same case here. So right now, everything is written with the single threaded execution or the GIL in mind. So only one thread will be executing at single point in time. But right now, we are introducing additional complexity. Like at any point, there can be multiple threads. So there can be like memory safety issues. So we have to do some additional work on every data structures, like the core code need to be changed. So this is like introduction of some additional work. So it will be like really difficult to match the performance. It won't like, compared to the default interpreter, it will not be getting better. But in the future, maybe the focus will go on to the free threaded mode, and yeah, they will work on some further optimizations. But always, I think if there are 2 versions, the default will be better for single threaded.
So thanks again for the wonderful talk, Adarsh. Can we all give a big round of applause to Adarsh?
Thank you.